Hello, geometry students. It's day 2 of proofs. So at this point, you've learned a whole bunch of reasons that you can say that we're going to be able to use throughout all the proofs that we do. What we are covering today are some somewhat specific reasons that we're going to be able to use, but it's kind of like a good mini proof starter, if you will. All right. So the first thing that we're going to talk about is called the addition postulate, which we actually did with numerical examples. Now we're going to be doing it with actual proofs. All right. So what the addition postulate is if we have two segments that we know have congruent pieces of them, and we want to add them up to show that the entire thing is congruent. This first one, it's telling you AD is congruent to CE. All right, so I'm going to write down AD is congruent to CE. Now, as you write it down, I want you to mark it in the diagram. So AD and CE, I'll put one single slash on each of those. Because there's no vocab term and there's nothing more I can say, I'm going to go ahead and put the second given in there with it. All right, so I'm going to say that DB is congruent to EB. All right, and I'll put a double stripe on each of those. And so my reason over here is because that's given to us. All right, what I want to prove is that AB, so the segment that goes from here all the way to here, is equal to the segment from C to B. All right? So the fact that I know that these little mini segments are congruent and then these kind of medium-sized segments are congruent, that would make sense that if I add them up, that the whole segments could be congruent, right? And so that's actually what we're going to do. We're going to take segment AD and add DB to it. So I'm going to say AD plus DB. And now if I added this side, let's add the other side. CE plus EB. And this is called segment, or sorry, you can say segment addition, but brain slip there for a second. That is called the addition postulate. And now we wouldn't finish with that because our goal, the last thing you say should always be what the proof step is. And so I want to rename this. So if I look at my diagram, AD and DB together, that would go from end to end, AB. So beneath it, I'm going to call that AB. And then CE, if I add EB to that, from end to end would be segment CB. And then that's it. That's the proof. And so I'm done. So it's literally a two-step little mini proof. So when I said back up top that the sum of the parts of the segments and angles are congruent, I should be specific. The little parts have to be congruent, and then the sums will come out to be congruent. All right. So if you want to add that, feel free. Otherwise, let's try another one where we can kind of see that in action. So I'm going to slide it on up. This time, instead of segments, you can see we've got a whole slew of angles to talk about here. So we've got angle BAD congruent to angle BCD. So we're going to do two things. We're going to write it down underneath the statements column. So angle BAD is congruent to angle BCD. And then we're going to also mark it in the picture. So BAD, that's that skinny angle right there. BCD, that's this guy here. Perfect. All right. Because there's no vocab term, go ahead and go right on to that next given. And when I say there's no vocab term, if it had said the word like midpoint, then we'd have something we could say from it. And it might be nice to stop and get that out of the way first. But since there's nothing to do, go right on to that next given. All right. DAC, that's this one at the bottom. I'm going to put a double stripe on that one. DCA, that's one on the bottom right, little double striper. All right. The goal, what we are trying to prove here is that angle BAC. So I'm going to take my red pen here. Angle BAC is that whole corner. I want to prove that that's congruent to BCA, this whole corner. Right? Well, imagine that there's numbers in here. If this was 10 degrees and that was 20, 10 plus 20 would be 30. If this was 10 degrees and that was 20, over here I'd have a sum of 30. So it makes sense if I add up the little angles and the little angles are the same, that the big angles would be the same. That's really all we're doing. We're just doing it with letters versus putting actual number measures in there. We're just making it a little bit more general. So at this point, now let's get to the adding. So we can add this left side here, that angle BAD plus angle DAC should be equal to, now we can add the right side, angle BCD plus angle DCA. All right, that is called the addition postulate. All right, let's rename it. These two together in the left corner became angle BAC. These two together in the right corner, those turn into angle BCA. Be very careful with the order so that you do not mix yourself up. All right, that's it. First two proofs, done. Easy. All right. So addition postulate goes hand in hand then with subtraction postulate. Right? So for subtraction postulate, you're taking two larger segments that are congruent, subtracting two smaller segments that are congruent from them, and then the result would be two congruent other small segments, if you will. All right, so it's the idea that we're going to take a large segment or angle, and then we're going to subtract from it part of it. I'm going to say part of the segment or angle. And then what you're left with is literally, I'm going to call the other part. So even though it's a really like weird generic way to say it, how I want you to think of it, how do I know that it's subtraction? If I'm starting with the whole thing. So when I say the large segment or angle, or I can think of this as the whole segment or angle, and then I subtract just part of it and I'm left with another small little piece, that's how you know what's going on. All right, so the first example is a really clear way to show that. You're starting with AC congruent to DF. So AC congruent to DF. Let's write it down because it's given. And now, if you like curly brackets, you could use curly brackets. Otherwise, stick with those straight brackets. All right, so here's AC. There's DF. So I know the whole things are congruent. There's no vocab term to talk about. So I'm going to put that next given right in here with it. AB is congruent to DE. All right, AB, and there's DE. So I don't even need to make it a second step. I just put it in there with that first given. Hey, look at what we're trying to prove. We want to prove that BC is congruent to EF. Well, here's BC, here's EF. It would make sense that if this whole length is the same as that whole length, and this little piece is the same as this little piece, then if we subtract and take that out, these remaining parts that I highlighted in red, those will be equal. So that's our goal here. So take the whole segment, that's AC, minus the part AB. That should be equal to, if I take the whole segment here, DF, minus the little part, DE. And then here's the other part. So when I rename it AC minus AB, I'm left with BC right here. All right, and then following the same logic for the second one, the entire segment DF, remove DE from it, and I'm staring at EF right there. All right, so the subtraction that took place is called the subtraction postulate. There we go. All right, you have one more just like this. And then we'll leave the other two for practice when I see you in class next. So sliding down here, sometimes the notation with this one can get a little bit confusing, but if you can keep in mind that it's just the same concept, then it's nothing more than taking the big angle and subtracting part of that angle, and you're left with the remainder, then it becomes pretty easy to grasp. All right. So angle EHG is congruent to angle GFE given. All right, let me highlight that. EHG is this big corner here, And then GFE is that big corner here. Now, rather than using the letters, we're just using the numbers that are written in them. So for this next part, it says angle 1 is congruent to angle 2. And let's mark that in here. So angle 1 is this angle. Angle 2 is that angle. All right. So if our goal is to show that angle 3 and angle 4 are congruent, that's the remaining angle right next to it, then it would make sense if I took that whole measure and subtracted this out, took that whole measure and subtracted this out, that what would be left would also be equal to one another. So let's do it. Big angle, EHG, minus the part of it, angle 1. Over here, big angle, GFE, minus part of it, angle 2. And then let's rename it. So make sure to look at the diagram and use the correct notation for this. So when we take this big corner in the left here and take angle 1 out, you're left with angle 3 underneath this. Over here, if I take this whole angle, take angle 2 out of it, I'm left with angle 4. So you do want to make sure it makes sense here, right? Otherwise, your logic doesn't really flow. And then that is referred to as the subtraction postulate. All right. So what you'll notice, we didn't use any of our new reasons in today's notes, but you're going to see them come back in another day or two. So we'll keep practicing those in class. All right. Don't forget to go answer the post-video question, and then we will start next time I see you with doing some of the practice here. Thanks for watching.